Okay, guys, so we're starting 11.3. Make sure you title your page, areas of irregular polygons. So it says the diagram shows a regular polygon inscribed in a circle. The center of the polygon and the radius of the polygon are the center and the radius of the inscribed circle. The distance from the center to any side of the polygon is called the apothem, which is, so focus. There we go. Is from the center down to the base. That's the apothem. The apothem is the height to the base of any isosceles triangle that has two radii as legs. A central angle of a regular polygon is an angle formed by two radii drawn to consecutive vertices of the polygon. To find the measure of each central angle, divide 360 by the number of sides. So now we're going to do example 1. So example 1 says in the diagram, ABCD is a regular pentagon inscribed in circle F. Find each angle measure. So the first one that they want us to find is AFB. So AFB. So this angle right here. So what they told us was, since it's inside of a circle, 360 divided by the number of sides, and it's going to give us that angle itself. So it's a pentagon, so 5 sides. So that means it's 72 degrees. Now we're going to look at angle AFG. So AFG. So this angle right here. Well, we know the whole angle is 72. This is going to be exactly half since this goes down the center. So this would be 360. 72 divided by 2, and that comes out to be 36 degrees. So angle AFG is 36. So now they want us to find angle GAF. So GAF, so this angle right here. Well, we can separate it and look at it as a 90-degree triangle. This is 90. We figured out this angle to be 36. We want to find this angle right here. So AGF. Slide this up a little bit. So we know that all 3 angles inside of a triangle have to add up to 180. So we make an equation out of it. 90 plus 36 plus angle A is equal to 180. Add these two together, like terms, 126 plus A equals 180. Subtract 126, and we get A is equal to 54 degrees. So that's example 1. Now we're going to go back to the book for our next theorem. Our theorem says area of a regular polygon. So the area of a regular n-gon with side length S, so this is the side length S, is 1/2 the product of the apothem A and the perimeter P. So we have 2 different formulas depending on the information that they give you. So to find the area, it is 1/2 the apothem, which is that height from the center to the base, times the perimeter, or if they don't give you the perimeter, you can figure it out with the number of sides. That's what n is, how many sides your polygon has, and the side length itself. So here we have example 2, and it says, you are decorating the top of a table by covering it with small ceramic tiles. The tabletop is a regular octagon with 15-inch sides and a radius of about 19.6 inches. What is the area you are covering? So now we're going to go off to example 2. Check that out. Example 2. My octagon came out really bad. So we want to know the area that we are going to cover. So I wrote down our formula already. It's 1/2 times the apothem times the number of sides and the side length. So let's list all the information that we have. So we know the n. It's an octagon, so it has 8 sides. We know the side length, which is 15, but we don't know what the apothem is. And the apothem is this height right here, straight down from the center to the middle base of our side length. So we can figure it out using the Pythagorean theorem. If we separate our triangle, P, Q, R, we know the hypotenuse, which represents our radius, so that's 19.16. And then the side length, so the whole side length is 15. Well, if you cut that exactly in half, this side length is 7.5. I don't know if it's my eyes or if it's not focused. Okay, so we're going to solve for our apothem. This is 90 degrees. So we're going to use the Pythagorean theorem. A squared plus 7.5 squared. Remember, it's always the legs on the left, and that's equal to the hypotenuse squared. Let me get my calculator. So 7.5 squared. So we have a squared plus 56.25 is equal to 19.16 squared. And we get 367.1056. Subtract 56.25. Let me just make sure I did that right. 19.16. Yes. Minus 56.25. Make sure you line up your decimals. I'm using the calculator. I'm going to take that answer and subtract 56.25. And then we get the a squared to be 310.8556. Now we want to take the square root of both sides. We're going to take the square root of 310.8556. Using all the numbers, that way it doesn't round, the rounding won't affect it as much. So the A comes out to be 17.63. So that's our apothem. So now we have all of our pieces of information that we need to find the area. Now we can plug it into our formula. A is equal to, instead of half, I'm going to use a decimal, so 0.5 times our apothem that we just figured out. The number of sides is 8, and our side length is 15, and we're just going to multiply straight across, and that'll give us our area. So 0.5 times 17.63 times 8 times 15, we get 1057.8. Is that inches? Why do they have something different? What did I do? 19, oh, is it 19? Oh, I put 19.16. Oh my goodness. So that, I'm like, something's not right. So let's fix this. This is 19.6, 19.6. I wrote it wrong on the example. So we're just off a little bit. So just make sure that you fix the calculations in your notes. This is the 3rd time I'm doing this video. I cannot do it again. I'm ready to go crazy. So the difference is 19.6 squared. So this comes out to be 384.16 minus 56.25. So I'm going to take that answer, minus 56.25. Comes out to be 327.91. Now I'm going to take the square root of that, 327.91. So it comes out to be 18.11. So cross this out, 18.11. Now we're going to multiply straight across. 0.5 times 18.11 times 8 times 15. There we go. So we get the area equal to be 1086.6, because if you went back and you looked at your book, you were like, okay, the answers are completely different. Now we match. So it was my mistake. I had put 19.16 instead of the radius being 19.6. I think I'm delirious at this point because the third time I'm doing this video. Okay, so example 3. So why is this not focused? I think that's better. I think it's the lights that throws it off too. So example 3, we're going to look at the book for a second because it's a picture, which I didn't draw. It was a little too difficult. So it says a regular nanogon is inscribed in a circle with radius 4 units. Find the perimeter and area of the nanogon. So here we have this picture. Nanogon has 9 sides. The only piece of information that they give us is that the radius is 4. That's it. No side length, nothing else. We got to figure everything out. So I'm coming back here. I didn't draw the picture with the polygon inscribed. I focused on the triangle itself because the only piece of information that we have is that radius, so we have to find the apothem, the perimeter, and the side length and everything else. So let's start with the apothem and the side length. Well, since we don't have any other information, we need to figure out this degree right here. And the way we do that is we take 360 and we divide it by the number of sides, which is 9. Nanogon means n is equal to 9 sides. So divide by 9, so we get 360 divided by 9 is 40. So this whole angle is 40. So now that's going to help us focus on the one triangle, which is MK, because this is 90 degrees. So we're going to focus on this one right here. This side right here is the apothem. So we know, and this is L, we know the hypotenuse is 4. We know this degree right here is 20 degrees because it's half of the 40. So using SOHCAHTOA, that's going to help us find the apothem and half of the side length. Because once we figure out MK, we have to multiply by 2. It'll give us the whole side length. So let's go through each one. So if we use sine, it's always from the perspective of the angle. So sine is opposite hypotenuse. By using sine, we'll figure out half of the side length. So sine of 20 degrees is equal to opposite over the hypotenuse, which is 4. So we'll be able to figure out half our side length. This is where we cross multiply. So MK times 1 is MK. And then we get 4 times sine 20. So 4 times sine 20 equals, I'm going to keep a certain amount of significant digits, 1.36808. Now that's half. So to get the entire side length, I'm going to multiply this by 2. but I'm keeping what's already in my calculator. So I'm going to take that answer and multiply by 2, and we get, so this is our S, 2.73616. Since it doesn't come out to be whole numbers, I like to keep a little bit of extra significant digits because then we won't be off with our final answer, rounding. So we figured out the side length. Now we need to go back and see which one is going to help us find the apothem. So if we use cosine, from the perspective of the angle, cosine is adjacent over the hypotenuse. So that's going to help us find the apothem. So cosine 20 degrees is equal to ML over the hypotenuse. Again, the proportion, going to cross multiply. So we have ML is equal to 4 times the cosine of 20 degrees. My calculator again. So we have 4 times the cosine of 20 degrees. And we get, so this is our apothem that we just figured out, 3.75877. So we can figure out our perimeter right away because our perimeter is our side length times the number of sides itself. So let's figure out our P. P is equal to 2.73616 times the number of sides, which is 9. That's going to be our first answer. So 2.73616 times 9, and we get 24.63. That's our perimeter. Let's see what they got. They said put 24.6, so we're good. Now we're going to find the area. I think we have all of our pieces of information. We have the apothem and we already have our P, so perfect. So 0.5, our apothem is 3.75877 times our perimeter, 24.63. We get our area to be 0.5 times 3.75877 times 24.63, and we get 46.29. Let's see what they put. They said 46.3. Perfect. So 46.3 when we round. Make sure to always round 46.3. Okay, guys, that's the end of 11.3. Make sure you do the homework. Make sure you pause the video when needed to take notes. Go back to the textbook if you have to and write down those theorems. Start the homework and make sure to watch next video 11.4. Bye.